Energy neither created nor destroyed, but changed from one form to another. That's the law of conservation of energy. And to better understand this statement, we will study energy transformation. And through the lesson, we will go to prove the conservation of mechanical energy, the transformation of energy in some applications, and the effect of technological applications on environment. So we have the pendulum moves on both sides around its rest position, where the speed of the vibrating pendulum decreases as it goes away from its rest position and became maximum when it passes its rest position. So when we pull the pendulum higher, the work done to pull the pendulum stored in a form of potential energy. And when you leave the pendulum, the potential energy changes gradually into kinetic energy, where the potential energy decreases by the same amount the kinetic energy increases. And at rest position, the speed of the pendulum is maximum, so the kinetic energy became maximum and the potential energy is minimum. And in this case, the mechanical energy equals potential energy plus kinetic energy. And as the pendulum goes to the higher position, the speed became zero, so the kinetic energy became zero, and the potential energy is maximum. And in this position, the mechanical energy equals potential energy. So why the pendulum keeps moving right and left around its rest position, keeping the mechanical energy constant? That's due to the exchange between potential and kinetic energy, where the decrease in the potential energy equals the increase in the kinetic energy. And the mechanical energy equals potential energy plus kinetic energy. So the moving body keeps its mechanical energy constant, which alternates between potential and kinetic energy, because the decrease in potential energy equals the increase in kinetic energy at any moment, and vice versa, where the resistance of air is negligible. So if there is no air resistance, the pendulum or any moving body will keep changing between potential energy and kinetic energy by the same amount. So the pendulum, as you pull it to a higher position, the potential energy is maximum and the kinetic energy equal zero, and as it moves to rest position, the potential energy decrease and kinetic energy increase. At rest position, the potential energy will be minimum and the kinetic energy will be maximum, and as it goes up, the potential energy increase and the kinetic energy decrease. And in this case, the potential energy is maximum and the kinetic energy equal zero. So why the motion of the children's swing is like the pendulum? Because in both of them, the potential energy and kinetic energy are interchanged without ending. If there is no air resistance, there will be continuous changing between potential energy and kinetic energy, and the sum of potential energy and kinetic energy at any moment will be a constant amount. So a moving pendulum has a potential energy of 0.8 joule at maximum displacement P. If the mass of the pendulum is a moving pendulum has a potential energy of 0.8 joule at maximum displacement P. If the mass of the pendulum is 0.16 kilogram and acceleration due to gravity is 10 meters per second square, calculate the height of the pendulum at maximum displacement and the kinetic energy of the pendulum at point P. So the potential energy equal 0.8 joule, the mass equal 0.16 kilogram. So as we know that the potential energy, just change the color, potential energy equal the weight multiply the height. So the height equal potential energy divided by weight equal potential energy is 0.8 and the weight equal the mass multiply the acceleration due to gravity. So 0.16 multiply 10 equal 1.6. That equal half meter. And the kinetic energy of the pendulum at point P. So at point P is the maximum height. So the kinetic energy at maximum height equal 0. Second, a moving pendulum, its mechanical energy equal 20 joule. Calculate the potential energy and kinetic energy at the highest point. So mechanical energy equal 20 joule. So at highest point, the potential energy equal maximum equal mechanical energy equal 20 joule. And at maximum point or at highest point, the kinetic energy equal 0. A moving pendulum, the mass of its pole is 0.4 kilogram. Its mechanical energy is 8 joules and its kinetic energy during passing through the rest position is 5 joule. Calculate the potential energy of the pendulum at rest position. So the mechanical energy equal potential energy plus kinetic energy. So the maximum kinetic energy equal 5 joule. So mechanical energy 8 equal potential energy plus 5 joule. So the potential energy equal 3 joules. The kinetic energy of the pendulum at maximum point equal 0. The speed of pendulum at the moment of its passing through rest position. So kinetic energy equal half mass multiplied by speed square. So the V square or the speed square will equal the kinetic energy divided by half mass equal kinetic energy equal 5 joules divided by half the mass, which is half multiply 0.4 kilogram equal, so V square equal 25. So to get the velocity, we have to take the roots of both sides. So the velocity will equal 5 meters per second.